Alright guys, we're going to talk about linear regression today, so let's go ahead and take a look at the definition. Alright guys, so the definition of a regression line, it's the best fit line of a given set of data that helps explain the relationship. So it's a line that's going to split your data points in half, or essentially follow the trend of your data points. You might see it called the best fit line or line of best fit. So you might want to write that down, because sometimes they'll refer to it as both the regression line or the line of best fit. Okay, and we can actually use this regression line to predict values. Okay, but in order to do that, we got to make sure that we have a strong correlation. So it's a strong correlation, and also we want to make sure that when we're predicting values, we want to make sure that it makes sense and that it's within the range of our values that we actually had our data from. And that'll make sense more when we do an example. All right, so how do we find the regression line? You can do it by hand, but that's more in the actual stats class. So we're going to use the graphing calculator. It's going to be very similar to what we did yesterday. So here's our steps. You're going to just follow your steps. Hit stat, put in your data. Remember, L1 is your X, L2 is your Y. Okay. Then we're going to go stat. You're still going to hit that linear regression. Okay. Then you're going to see it as the Y equals, I think in the calculator it says AX plus B. Okay, so you're just going to plug in your M, which is your A term, and your B, which is the y-intercept. Okay, always round your A and your B to 2 decimal places. Okay, all right, let's take a look at an example. All right, so John's parents recorded his height at various ages up to 66 months. Their data is recorded in the table below. Find the line of regression. So I'm going to go ahead and put these. Remember, this is your L1, this is your L2. So go ahead and put that in your calculator. All right, this is what it should look like. Okay, once you put it in the calculator and do that stats, lin reg, it should look like that. Yesterday we dealt with the R values. We're not going to deal with that today. We're just going to look at this part right here. Okay, so we're going to go ahead and rewrite our equation, because the linear regression is just an equation of a line. So we're going to go ahead and do 0.34 x plus our b, which is our y-intercept, so 22.32, and that is our equation of our regression line. Okay guys, let's just kind of take a look at this. So let's interpret the meaning of the slope of this regression line. Okay, so my slope is this 0.34. Okay, so thinking that slope, it's positive, so that means that this is going to have a positive correlation. Okay, so just by looking at this line, it kind of tells me which way my line goes, that it's going to be going in a positive direction just by looking at the slope. Now, also what we can do with the regression line is we can also use it to predict values. So I'm going to go ahead and look at this. How tall would you expect John to be when he's 50? So we're going to use that regression line for it. Notice how I'm not going to look at the table. I just use my line to predict. Okay, so I'm going to just use this 50. That's going to be my X. So I'm going to go ahead and do 0.34 times 50 plus 22.32. So I'm just going to plug that in my calculator, and I get 39.32. And we're talking about inches. I know that from the table that we were just looking at. Okay, let's take a look at this projection. So using our regression line, how tall would John be when he is 20 years old or 240 months? All right, so does this answer make sense, and does it break one of the rules? So let's just first do the first part. So we're going to use that same equation, 0.34 times 240, and then it was plus 22.32. So when I do that in my calculator, my answer ended up being 103.992 inches. Okay, now let's just think about that real quick. There's 12 inches in a foot, so if I divide that by 12, okay, that means that John was about 8 foot and then some, so 8.66 feet. Okay, now let's think about that. Does that answer make sense? Does it make sense for a 20-year-old to be 8 foot 6'6"? That doesn't really make a lot of sense. Now the reason is because we're talking about a regression line. So here's my scatter plot, right? What's the problem with if I'm using this line to predict it if we're talking about heights? Well, let's think. When people grow, they don't keep on growing forever. There's a chance where they start just plateauing. Okay? So this doesn't work because that's not really in the data points that we had. It's predicting too far into the future, and we know that people stop growing at some point. So sometimes you have to be careful when we're using this line to predicting future values. All right, so the last little thing, I want us to draw a regression line for the following scatter plots. So a regression line is the line of best fit. So we want it to kind of cut our points in half. We want to have about the same amount of points on top as there are on bottom. So I'm just going to go ahead and draw in a line that kind of cuts my points in half. I really didn't want to put an arrow there. Okay, so that's my line right there. Same thing here. I want to kind of cut my points in half. Well, there's my line of best fit. So if whoever wants a line of best fit, just try to kind of cut your points in half and follow the trend of your lines. Now go ahead and get started on your class kick. Best of luck.